Today's lecture is about operations on functions. Given two functions, can we add them together? Can we subtract them from each other? Can we multiply or divide them together? Today we're going to discuss that. So, for example, if you have two functions f and g, so if you're given the two functions fx and gx, and they ask you to calculate f plus g of x, this means in notation, f plus g of x means f of x plus g of x. That means add the two functions together. It means corresponding y value of f plus the corresponding y value of g. Add them together. If it's a subtraction, you just subtract the functions from each other. Multiplication, multiply them together. Division, f divided by g of x. That means your function f of x is in the numerator, g of x is in the denominator. There are some restrictions on the domains. What would be the domain of the new function? So if you add two functions together, or subtract or multiply two functions together, what would be the domain? The domain would be the intersection of both functions, because you want to be able to get y value from each one to add them together, or the y value from each one to subtract or multiply them together. In case of the division, beside having the intersection of the domain, you have one more restriction. What is the restriction? Is that the denominator cannot be 0. If it is 0, then you have an undefined value. So plus, beside the intersection of the domains, you still have to consider that the denominator cannot be 0. So you exclude the points where the g of x equals to 0. So this is for those x's where the g of x actually equals to 0. I should have wrote it like this. You want to exclude those points, the x values where the g of x equals to 0. Okay, here I will show you through the example. Okay, so let's say we're given three functions in this case: f of x, x squared plus 1, g of x, x minus 2, and h of x, x squared minus x plus 6. And they ask us to calculate f of f plus g of x. That means, in definition, this means f of x plus g of x. Add the two functions together. And what does it add up? F of x is x squared plus 1, g of x is x minus 2. So I'm going to add them together. And if you can simplify it. X squared plus x minus 1. This would be the f plus g. There is nothing complicated about that. You're just adding the two functions together. How about if they ask you what is f minus g of 0? This means f of 0 minus g of 0. The input given already is 0. So for both functions, you replace 0 in. F of 0 would be 0 squared plus 1. 0 squared plus 1. This is f of 0. And I subtract it from g of 0. G of 0 is 0 minus 2. I'm replacing 0 into the function g. You should use parentheses because this subtraction will multiply into distributed into both parentheses if this is not a constant. In this case, it's a constant. It really doesn't make that much difference. 0 plus 1 is 1, and you would have negative 2. 1 minus minus 2 becomes 3. So this is f minus g of 0. Here, what if is f times g of negative 1? This means f of negative 1, the input is negative 1, multiplied by g of negative 1. Figure out what is f of negative 1. How do I do that? I replace negative 1 into the function f. Negative 1 squared plus 1. Whatever this is, this would be f of negative 1. Multiply by g of negative 1 is replace negative 1 into function g. You'll get negative 1 minus 2. So calculate. This is 2. This one is negative 3. You multiply them together, result is negative 6. What is the domain here for each function? The domain of f of plus g of x is what? It's the domain of f and domain of g, intersection of them together. Domain of f is all real numbers. There is no restriction. Domain of g is all real numbers. So the domain would be all real numbers intersect with all real numbers, still all real numbers. There's no restriction. F minus g and f times g, same property. But you cannot discuss f minus g of 0 and say what is the domain of that, because this is already a constant. It's not a function anymore. It's just a y value. If they ask you what is the domain of f minus g of x, means you already have a function. What you get is x squared plus 1 minus x minus 2. Now this is a function. You'll get x squared minus x plus 3. This function has domain R as well, all real numbers. You can replace any input in here and you will get a corresponding Y value. Same for multiplication. Yeah, here in the other case, when you have division, you have to be a bit more careful. For example, if they ask you calculate f divided by g of x, this means you want to figure out what is f of x divided by g of x. This is f divided by g of x. They ask you to do that. That means find out what is f of x divided by g of x. It is, as it's given, x squared plus 1 divided by x minus 2. This is the function. But what if they ask you what is the domain? Domain here was all real numbers for R, for f. For g, it is all real numbers. So I can say the domain is all real numbers, except I have to exclude some points. What points do I exclude? I exclude the points that makes the denominator 0. Because if the denominator is 0, then you have an undefined fraction, as we discussed for rational functions. So I want to figure out where x minus 2 equals to 0. X would be 2. So I have to exclude that point. Because if I replace 2 into the function, then the function f divided by g would be undefined. You would have 2 squared plus 1 is 5, divided by 2 minus 2 is 0. You would get 5 over 0. That's an undefined value, not possible. Here, what if it was g divided by f? G divided by f, x minus 2 divided by x squared plus 1. So x minus 2 divided by x squared plus 1. What is the domain? Again, all real numbers minus, because all real numbers is the intersection of f and g domain, minus where the denominator is 0, x squared plus 1 equal to 0, x squared equals negative 1, x equals square root of negative 1, plus or minus. This is through the radical property, square root property, and this is not a real number. This is a complex number I, and does not belong to real value. So we assume this is it's not an acceptable solution in real values. So therefore, this has no solution. This has no solution. So therefore, there is no point to exclude. So what is the domain? Domain is still all real numbers. This denominator is never 0. Whatever you replace there, it's never 0. Replace 0, it's 1. Replace negative 1, you will get 2, and so on. So there is no restriction for this function. You can replace any number that you want. Here there was another function. I had the function h as well. What if they ask you to calculate g plus h of 1? Think about it. It means g of 1 plus h of 1. I just wanted to show you that it's not always using f as a function. You can use g, h, k, whatever. So g of 1, you replace 1 into the function g, you get 1 minus 2. I'm going to write 1 minus 2 plus, if I replace 1 into the function h, you'll get 1 squared minus 1 plus 6. 1 squared minus 1 plus 6. 1 squared minus 1 plus 6. Add them together, and what you get is, this would be negative 1. Here you would get 6, so it would be 5 at the end as the result. This is 6. Now what g divided by h? G divided by h is x minus 2 divided by x squared minus x plus 6. What is the domain? The domain of g and h, since both of them are linear and quadratic function, the domain of each one was real numbers. So what is the total domain of g divided by h? Again, this is g over h of x. G function divided by h function. What is domain? Domain is all real numbers, except where do you get the denominator equal to 0? You have to exclude those points. So figure out where x squared minus x plus 6 equals to 0, and take out those points. X squared, you can factor this as x minus 3, x minus 2 times x plus 3. What you get is 0, x is 2, either x minus 2 is 0 or x plus 3 is 0. So you get two solutions. I exclude these 2 points. Domain cannot contain 2 or negative 3 because it makes the denominator 0. But here's the important part. I can simplify this function after I find the domain. So I still have gx divided by hx. And what do we have is x minus 2 divided by x squared minus x plus 6. This is something that you should be careful. If you're simplifying a function, you should be careful that you always find the domain first, then try to simplify. Here, denominator, if you remember, you can factor it, x minus 2, x plus 3. You can cancel out these two. What is left is 1 divided by x plus 3. So I simplified the function to 1 divided by x plus 3. But the domain of this function is all real numbers except negative 3. You can replace 2 here, but you cannot replace 2 in the original function. So don't find the domain at this point. Domain always you find it before simplifying the function. So the domain you should always find it here before you simplify the function. At this point, if they give you this as the original function, then sure, the domain would be all real numbers except negative 3, because negative 3 makes the domain 0, makes the denominator 0. But original function is g divided by h, has this form of x minus 2 divided by x squared minus x plus 6. So therefore, the domain should come from here. That's why we figure out the domain before simplifying. Okay, this is addition, subtraction, multiplication, and division. It's just basic calculation. Now here's the important part of our topic for today. Is the composition of functions. First is notation. FOG of x is a common notation. FOG of x means f of g of x. And you might ask, what does this mean? This means g now is not a multiplication. This is an input into the function f. So inside the function f, normally you replace it x, y, or whatever. Now in this case, you have a new function. Let's call it star, box, whatever. So that new function that you replace inside is the g function. You can look at it the other way. If they ask you what is GOF of x, that means f is an input into the function g. The way that you read it is f is an input into the function g of f of x. Okay, here's an idea of what does this operation do. Let's assume you're given the two functions f and g, and g picks up a number. You replace 1 into g and ends up at 2. And if you replace 2 into f, where does it end up at? And ends up at 5. When you calculate the FOG function, the FOG function takes an input 1. So here, FOG of 1 means 1 goes into f. And what do you get in this case? You will get 2. Then 2 goes into f. Sorry, 1 goes into g, and what do you get is 2. Then 2 goes into f. What do you get as the result? Is 5. So the outcome of the FOG is 5. So what you do is you're trying to erase this middle step and say, starting from 1, where do I end up? I end up at 5. That's what the composition does for you. You combine two functions and write those one function that operates both functions at the same time. Here we can go through an example together. For example, given f and g is g of x is x minus 2 and f of x is x squared plus 1. Here, let's go through this. Let's say if they give you 0 as an input for g function and ask you what is g of 0, you would get 0 minus 2. So what you get is negative 2. Negative 2. So 0 goes to negative 2. I'm going to write them in order. How about negative 1? Where does negative 1 end up? G of negative 1 would be negative 3. Right? Negative 1 minus 2. Negative 3. G of 1. These are just sample numbers so you see the process. G of 1 would be 1 minus 2. You'll end up at negative 1. So I'll end up at negative 1. Okay? I should have picked maybe 2 so to end up with 0. Doesn't really matter. So 0 goes to 2, negative 2. Negative 1 goes to 3, 1 goes to negative 1 through the function g. Okay, now let's try figure out what is the outcome if I replace -2 into f. Where does it end up? So if I figure out what is f of -2, I will end up with -2 squared plus 1. 2 squared, use parentheses, plus 1. You'll get 5. So I'll get 5. If I replace -3 in it, where do I end up as -3 squared plus 1 equals 10. I'll end up with 10. If I replace -1, f of -1, you will get -1 squared plus 1, which is simply 2. So you'll end up with 2. Okay. So now think about this. This was two functions if you operate back to back. Here, the point that we started with was 0 and -1 and 1, and we ended up at 5, 10, and 2. Now, I'm going to introduce a function that without any other, that operates this mapping without any other function. So I'm going to call this function, let's say, fog of x. I'm going to call it x squared minus 1. Sorry. Is it x squared minus 1? X minus 2 squared plus 1, sorry. X minus 2 squared plus 1. Okay. If I think about this function, fog this way, x minus 2 squared plus 1. Now try to replace these numbers. If I replace 0, what do I get? 0 minus 2 is -2, squared is plus 2, plus 1, I'll end up exactly at 5. If I replace -1 in there, -1 minus 2 is -3, squared is 9, plus 1, 10, I'll end up at 10. If I replace 1, you'll get -1, 1 minus 2 is -1, squared is 1, plus 1, exactly 2. So what did I do is I skipped this middle step and I went straight from the given input to the out result. And now the question is, how do I get this function? And that's by doing this composition that we're going to discuss through the notation. You replace the function g inside the function f. So g operates first, then f operates. So here, and how did I get this function? This is the question. So if they ask you to figure out what is fog of x, by definition, this means find out what is f of g of x. You already have the g of x. You're always starting with, if you're simplifying a function, you always start from the inside. What is g of x? G of x is given, x minus 2. So I replace g of x with x minus 2. Okay, this is not multiplication, by the way. It's just an input. So what is f of x minus 2? Into the function f, instead of x, you should replace x minus 2 every time you see x. So this goes an input for x. Every time I see x, I replace x minus 2. So I'll get x minus 2 squared plus 1. And what is this? This is exactly the same function that here we discussed, x minus 2 squared plus 1. Okay, so the composition of the function is just you're replacing one function inside the other as an input. And here, if you try it the other way, you can try it the other way. What if they ask you what is GOF of x? First, figure out what does it mean. This means g of f of x. Start from the inside. Do I know what f of x is? It's given. So g of f of x is x squared plus 1. I replace f of x with x squared plus 1. So where does x squared plus 1 ends up? Inside the g function. So every time I see x, I replace x squared plus 1. So I get x squared plus 1 minus 2. Instead of the x, I replaced x squared plus 1. And you can simplify it, it's x squared minus 1. I just wanted to show you that these two are different. It's not the same thing. This one is x minus 2 squared plus 1. The other one is x squared minus 1. So don't expect the result of the composition to be the same thing. How about if I ask you what is FOG of let's try 1. Now it's not x. So what does it mean? That means we're looking for f of g of 1. As by definition, 1 goes into g. So I figure out what is g of 1 first. What is g of 1? G of 1, replace 1 into the function g. You'll get 1 minus 2. Actually, you don't need to write this step, but I'm going to write it this way. 1 minus 2 is negative 1. You can always simplify the inside. I replaced the 1 into the function g, and I got negative 1. So now the question is, what is f of negative 1? Into the function f, replace negative 1. What you get is negative 1 squared plus 1. Where do you end up? At 2. And if you remember, if we start from 1 as an input, where did we end up? We ended up at 2. That's exactly what we calculated here. You start from 1 as an input and you go through the FOG, where do you end up is at 2. Okay, let's try another one. How about if they ask you, what is, let me use a different color. What is FOF of 3? Maybe 3 is a very large number. Let's try 0 or something. What does it mean? That means f of 0. That's an input. 0 goes into the function f. And here, let me write down the function f here. It was x squared plus 1. I hope. Yeah, f of x was x squared plus 1. So what is f of 0? F of 0 would be 0 squared plus 1, which is simply 1. So this inside f of 0 is 1. I can replace 1 for it. So now the question is, what is f of 1? F of 1 is 1 squared plus 1. This is 1 squared plus 1 is 2. So that means we had the function f. It took 0 to 1. Then again, we applied the function f. It took it to 2. It's not always adding 1. You always square it, then add 1. That's the operation of the function. If you pick a different number and try f of, for example, 2, what you get is f of 2. F of 2 is 2 squared plus 1. F of 2 would be 2 squared plus 1, which is 5. So this inside would be 5. I'll have f of 5. Then what is f of 5 would be 5 squared plus 1, which is 26. So if I start with 2, for example, I'll get 5 in the middle. Then I'll end up at 26. So what does do the FOF? FOF is applying f twice. First as on the input, then on the result of the input. Here's one more example. This time I picked like 4 functions to go through, a bunch of them, and calculate a couple of examples. I just wanted to see, I wanted you to see the idea of this decomposition. Then what it does is it starts from the domain and goes through the g function. It gives you y value in g, y in g. Then that y value in g goes to as an input of the domain for f. Then what do you get is some y value in f. We can combine all these and say, okay, I'm going to write it as 2 functions composed together. Here, let's try to figure out maybe FOG of x, GOF of x, HOF of x, I think maybe K of G of x. How about that? K of G of x, and maybe one more. F of K of x, FOK of x. And after that, we try numbers as well. Let's figure out the functions first. Okay. So what is FOG of x? Always write down the definition. This means g is an input to the function f. Do I know the g function? Yes, it is given. So I replace the g of x with the given function. It is x squared plus 3. Okay, so where does x squared plus 3 go? X squared plus 3 is an input. This was the same as g, by the way. I replaced g with x squared plus 3. It's an input into f function. So into the f function, every time I see x, I replace it with x squared plus 3. So what do I get? It's square root of x squared plus 3. This is the f of g function. How about the g of f function? Is the other way around. It is g of f of x. So now what is the input? Is f of x function. So I have, instead of f of x, I can replace square root of x, because f of x is square root of x. I just replace square root of x. Now where does square root of x go? It goes into the g function. Every time I see x into the g, I replace square root of x. So I will get square root of x squared plus 3. You can simplify it after you find the domain. So the domain here is only positive numbers, because square root of x cannot have a negative number inside. After you find the domain, you can simplify and say square root of x squared is just x, and you'll get x plus 3. Okay. It's important that if they ask you to specifically find the domain, you should always find the domain before simplifying. I do not find the domain here. You always find the domain before you simplify. At this point, before you simplify, you find the domain. Okay. HOF. What is HOF? It is h of f of x. Where does f of x go? F of x goes into the h function. What is f of x? It is square root of x. So where does square root of x go? It goes into the h function. Into the function h, instead of x, I'll use square root x minus 1 with the absolute value. There's nothing I can do to simplify it, so this is the function. How about KOG of x? Let's try KOG of x. We have k of g of x. Start with the inside. What is g of x? Keep the k parentheses. G of x is x squared plus 3. So I replace g of x with this. If you write down this step, you're just replacing at this point. You replace g with x squared plus 3, because g of x is x squared plus 3. And then what the question is, what is the answer to k of x squared plus 3? That means replace k of x squared plus 3 into the k. Into the k function, instead of the x, we replace x squared plus 3 every time we see x. And you should replace it everywhere. So this would be x squared plus 3, x squared plus 3, and you have a plus 1. You can simplify it a bit and say this is x squared plus 3 divided by x squared plus 4. Here's one mistake. Do not cancel out these two. That they do not simplify. There's addition between. Okay, so this is your function. How about f of k of function x? So it would be f of k of x. What is the k function? I keep the f. K function is x divided by x plus 1. There. This is the k function. So instead of kx, I replace the function. And where does x divided by x plus 1 go? It goes into the function f. So into the function f, instead of x, I replace x divided by x plus 1. I will get square root of x divided by x plus 1 underneath the square root. Okay, now let's try figuring out a couple of values, because in all these, I only asked you for the function. What if they ask you to find, for example, g of f of, I don't know, 0? Let's figure out what do we get. G of f of 0 means g of f of 0. F of 0, what is f of 0? Into the function f, if I replace 0, what do I get? The square root of 0. Square root of 0 is simply 0. So instead of f of 0, this whole thing is 0. So I have g of just 0. And square root of 0 is 0. So what is g of 0? In the function g, instead of x, you replace 0. 0 squared plus 3. 0 squared plus 3. What do you get is 3. This is one way to calculate. The other way is you already found the g of f function here. And what we got was x plus 3. So if they ask you what is g of f of 0, g of f of 0, since you already have the function, just replace 0. 0 plus 3. What you get is simply 3. If you don't have the function, you can go through this process. But if you have the function, it's not necessary. So if they ask you, for example, find out what is HOF of 5, you can go through the process, replace that to 4, not 5. So you can simplify. You can go through the process and say, okay, I'm going to calculate f of 4, then replace it into the h. You can do this and say h of f of 4. Figure out what is f of 4. F of 4 is, figure out first this one. F of 4 into the function f. I replace 4. Square root of 4 is simply 2. So what we get is h of f of 4 was 2, square root of 4. Then I replace 2 into the function h. Into the function h, here, replace 2. You will get absolute value of 2 minus 1. Absolute value of 2 minus 1. What is that? It's simply 1. But since I have the function HOF, I could have done it right away. And say, I replace 4 into the function HOF. What is it? It's absolute value of square root of 4 minus 1. What do you get? Simply 1. And I didn't need to go through the process again. Okay. So if you have the functions, you can always calculate. For example, if they ask you to calculate KOF of 3 or something, into the function. Yeah, here we don't have the KOF function. If you look at these, there's no KOF. So now there is not an option. Either you find the KOF function or you replace this 3 into the KOF. So if I replace 3 into the f function, let me write this. So let me change that 3 again. I'll maybe keep it as that. So you have the option to see sometimes that you cannot simplify. This means k of f of 3. What is k of f of 3? Into the function f, replace 3. What do you get is square root of 3. So you get k of square root of 3. Because f of 3 is simply square root of 3. Now square root of 3 goes an input into k. The k function, replace square root of 3 for x. You get square root of 3 divided by square root of 3 plus 1. I replaced square root of 3 for x. This became square root of 3. Square root of 3. And again, do not cancel out these two. That's not possible. There is an addition here, plus 1. So this is your result. Don't need to rationalize it at this point. Okay. I hope this is clear enough on the composition of function. Normally we stick with simple compositions at this moment. Just only these cases. Okay. So far what we've discussed is if you're given two functions, you can combine them together and put one function as an input for the other and so on. What if they give you the composition? What if I give you this and ask you, can you go backward and tell me what was h and f? If I give you square root of x squared plus 3, can you go backward and tell me what was g and f, and so on? So the question is, if you're given the composition like this, if you're given f or g already, can you tell me what was f and what was g? And here, this is what we call it expressing a function as composition of two functions. So you want to break it up into two separate functions, two simpler functions. Here is one thing that you should know. It's not a unique solution that you always get the same function. I can have multiple solutions for the composition if I want to break down this function. It means if you want to go, for example, if you want to go from 1 to 5 from FOG, there's multiple ways. It's not always going from 1 to 2, then from 2 to 5. You can always go to 3, then 3 to 5. You can go to 5, then keep 5 to 5, and so on. There are multiple ways that you can go through this process. But if it was f and g given, you're given f and g, then there is one way through f, one way through g, so the composition would be unique. But if you're not given this middle function, you can go different functions, create different middle points, and end up at the same out value. So this breaking up the function is not actually a unique solution. You can have different solutions. Normally we pick the easiest one, the one that makes more sense. And I'll show you how to do that. I can erase these stuff now. Okay. Sorry about these dots, they do not go away for some reason. Okay, FOG of x is given as square root of 2x squared plus 1. Here, a simple option is to think about it as f of g of x is given square root of 2x squared plus 1. Okay, this is you have an input and an output. Here I'm going to highlight. I'm going to call an inside function something. The gx, I'm going to highlight the function that I want. Maybe I'll call it x squared. Here's an example of it. If I highlight gx as x squared, then I can say gx, I'm going to call it x squared. What is fx? Fx. Wait, actually, maybe I should say what is f of... let me erase this as well. What is f of box? If I call this a box, what do you get is square root of 2 times box plus 1, right? Because the box, if it was gx and it was x squared, then I will get 2 times x squared plus 1. So if this was x, f of x would be 2x plus 1. So I can say I have the option to pick gx as x squared, and f of x would be square root of 2x plus 1. And if you do the composition, you will see that FOG is simply exactly 2x squared plus 1 square root of that. This is one option. The other option would be, there are a million of them. You can pick your own case. Here, I'll pick another one. For example, if I pick g of x to be the whole thing, 2x squared plus 1, all the inside. So if I pick g of x to be all this thing, so then what is the corresponding box? F of box is square root of box. So what is f of x? Is square root of x. This box is just a variable x. Okay, that's another option. What if I want g of x to be only 2x squared? Let me use a different highlighter. What if I want g of x to be only 2x squared and keep the 1 out? Then what is f of x function? The f of x would be, I hope you can figure it out. I call g of x to be this highlighted. So what is left is square root of this highlighted is your box, which we consider an x variable, x plus 1. This would be the g function. The f function, sorry. So you see that there are multiple ways that you can create the function. Normally, this is what they do, is they pick this one because it's the simplest form. F is very simple, square root, g is a quadratic function, 2x squared plus 1. But the other ones are possible as well. Here is another example. I will write FOG as f of g of x, and it is given as x minus 1 squared plus 3. You have multiple choices. You can say, okay, this is g function, I want it to be only x minus 1. So if I do that, what do I get? If I say g of x is x minus 1, then what is f of, we call this a box. What is f of box? It is box minus, not minus 1, box squared plus 3. So if I call this box an x, this is x squared plus 3. You'll get f of x is x squared plus 3. This is an option. What if I don't want that? What if I want to... This is all depending on what is the choice that you want to pick. Sorry about that. Let me rewrite this. If I can highlight it again. F of g of x is given as x minus 1 squared plus 1, 3. But now, what if I want g of x to be the whole thing, x minus 1 squared? I want this part. I want to keep the 3 out. So now, g of x, I call it to be x minus 1 squared. What would be the f function? I hope you can guess it. Call this x. This would be x, because they're the same thing. We introduced it to be the same thing. We call this highlighted sections to be equal. So I have x plus 3. And you can always try the composition. Figure out what is, if you're given f and g now, try to figure out what is f of g, of x. You should get exactly x minus 1 squared plus 3. Because this is x minus 1 squared. It goes into the function f, and it turns out to be x minus 1 squared plus 3. Otherwise, you've made a mistake. Okay, here's another example. These are all depending on what is the choice that sometimes they give you one of the functions. Sometimes they give you, for example, that x minus 1 is g. Then you have to uniquely figure out what is f. But if they don't give you either one, you have multiple choices. You can pick that, pick this one, and so on. Okay, here is another example. F of g is given as square root of x plus 1. So f of g of x is given as square root of x plus 1. They ask you, what do you want the g of x to be? I highlight maybe square root of x only. And say, this is what I want as the g of x. So now, if I say g of x is that, is square root of x, then what is f of x? Again, this to gx, the highlighted are equal. So I'm going to name it as x. F of x would be, you can call it star if you want. The stars are equal because we call them to be the same. So what is f of star? F of star would be square root of star plus 1. Instead of star, normally we use variable. So we do not stick with the star. We use x. We say this is x as well as this is x. So we say f of x equals x plus 1. Okay. This is an option. What if you want to pick the plus 1 with it as well? What if you want g to be this whole thing underneath the square root? So if you want to pick, maybe I should rewrite the function here. F of g of x is given as square root of x plus 1. What if I want the g of x to be the whole thing? Then I'll say g of x equals square root of x plus 1. What is f of x? Again, if you get confused with the x part, just call it star. What do you have is f of star equals square root of, I call this whole thing star again, because they're highlighted to be the same thing. We introduced g of x to be equal to that. So what is f of x? The square root of x, because the star can be replaced with an x. This is another way. Okay, so I hope these were clear enough for you to decompose functions into multiple, decompose a function into multiple functions. Okay, I'm gonna stop here.